Hello, this tutorial is about parameter mapping in Sema using the default language and using machine learning in the JavaScript window. The broad scope of this tutorial is to think about the process of using machine learning as a creative material. And so how do we integrate neural networks with creating sound or music with live coding? And what's the processes around how we edit and manipulate sounds and in tandem edit and manipulate machine learning models. The code in this tutorial is preloaded in both windows when you open it. We've got some sound synthesis and mapping code here, and we've got code to run a neural network here. We're not going to go into too much detail about kind of line-by-line detail about how this code works. We're just going to focus on the larger process of how you train and run and kind of manipulate a neural network with live coding. So here's how this works. We've got a command here. It's 2JS, which sends data from the audio engine over to the JavaScript engine. 25 times a second, we're sending both mouse coordinates, mouse x and mouse y, over here. In the JavaScript window, we're going to do some processing with these mouse coordinates and then translate them into control signals to control this synthesis process here. From this line down, this synth is an FM synth. We don't really need to know the details about how this sound synthesis is working. The key point is that there are 7 parameters that control this synthesizer. So it's just like if this synth was a hardware synth, it would have 7 sliders to control it. And we want to control those sliders using machine learning. Why is that? Well, FM synthesis is quite well known for being quite unintuitive to use. So when you edit the parameters manually, they're quite non-linear. It's not always easy to try and realize the sound that you're aiming for. But what we can do with machine learning is create a model that lets us explore trajectories through the parameter space of this synth. So through all the different possibilities, all the different sounds that we can get out of this synth, using something that's a bit more intuitive, which here is the mouse. So the mouse can be a fairly expressive instrument for exploring sounds. We're converting 2 numbers, so 2 coordinates from the mouse, into 7 coordinates, or 7 parameters for this synth. And in between, we'll have a neural network which learns how to do the mappings. And part of the creative process of creating these mappings is in how we choose to train this neural network. To start with, let's see what this synthesizer sounds like. I'm going to start the audio and we'll just hear it. It's on a random setting at the moment. This synth is kind of capable of some quite complicated sounds. It's got a feedback connection here, which means it can do some really interesting, perhaps unexpected sounds for a small synthesizer with not so many parameters. So it's quite nice as a target to explore with neural networks. There's a lot of variance in the model. In this script, there are some pretty clear instructions on the kind of process of how to run it and how to train the model. We don't really need to go into too much detail about what all this stuff does. We'll just focus on which blocks to run when. So the first instruction is to run this block of code. I'm just going to clear this console, and then we're going to move down. We won't worry about what all this stuff does for now. And the first thing here is we've got an array of numbers, 7 parameters that can control this synth. And I can set these numbers manually. I can live code these numbers if I want. what they're doing is when we send them through, they're arriving in these from.js functions here to get mapped into the synthesizer. I'll just show a demo of how that works. I'll start the sound again. So you can try that, and you'll see that it's quite challenging to explore the space of this synthesizer. Another way we can explore it is to create random settings for the synth. So we might just land in an area that we think sounds good. As you can hear, there's quite a bit of variance in the sounds we can get from this patch. Let's train a model then to explore this sound space. The training process is that I choose a random setting for my synthesizer using this command here, and then I press train, and when I press train, I'm going to be moving my mouse around a specific area of the screen. What this will do is create training data that associates an area of the screen with a particular set of parameters I've chosen for the synthesizer. And then you can do this, repeat this for different areas of the synth. So perhaps then I'll choose a different sound and then move my mouse down here and then collect some more data which associates this area of the screen with that different sound. I'm just going to do that now. I've collected some data then with one sound associated with this area of the screen and a different sound associated with this corner of the screen. The next thing I'm going to do is train a model which will create a mapping between these two sets of data. If I run this block of code, it's going to create an untrained neural network. We won't worry about exactly what all this means now. The main thing that it's a model which we're going to refine to do the mappings that we need by showing it the training data. In this section of the code, this takes the data that's been collected and converts it into the correct format for TensorFlow, which is the library we're using here for machine learning. And here, this is where we actually train the neural network. And when I hit the train button, we're going to see a loss number appear in this screen. And we want that to go quite low, say down to 0.02, 0.01. I'm going to train it in groups of 10 at a time until it gets to the right amount, the right loss. So actually that's trained pretty well already, just in 10 epochs. What you can do just to quickly test this model is you can just run the predict function, which will take the current recording of the mouse movements and convert it into a set of parameters. So we've got some data out of there. That just shows that the model's working. But what we want to really do is use this live. So I'm going to switch the sound on again, and we'll see if the model has picked up the mappings correctly. So there should be one sound in this corner and the other sounds that I chose in this corner. we can see then that the models picked up these sound mappings fairly well. So we had a fairly distinct sound, a cleaner sound in this corner, and a kind of more complicated sounds down in this corner. And where the model hadn't been seen training data, so we didn't give it any training data for the middle area of the screen, well, it made its best guess. So it created quite an interesting interpolation as you move the mouse across the screen. So that's a model trained. We've created some interesting mappings. You could probably make some music with that. What we could do is, the next stage in this process is to refine this mapping. So we can think of neural networks as something that's quite malleable. We can keep kind of adding data into the training set and retraining them and refining them to the task that we want them to do. So let's do that now. I'm going to find one more sound and associate it with this area of the screen. Now I'm going to go back and retrain the model with this extra data. That looks like it's trained fairly successfully, so let's hear what this new mapping sounds like. So that's ended up with quite an interesting mapping that covers all areas of the screen with some quite interesting variation. And you can experiment with this yourself. You can try lots of different sounds. You can add new training data into the dataset and retrain. You can just start the model off again by rerunning the code from the top. Other tasks you could try would be to change some of the synthesis code here, or create your own code which these parameters map into. And this will get covered in the second part of this tutorial, which is more about the generic parameter mapping or regression process that we're exploring here.